What's up, guys? I hope you all are doing well. Welcome back to my YouTube channel and welcome back to another YouTube video. In this video, we will be looking at exercise 64 of our Python exercise tutorial series. Without any further ado, let's get to it. So guys, one thing I'd like to mention, right, or a few things rather that I'd like to mention to you is, firstly, you see this exercise 64 onwards until further notice, we will be looking at Python programs and Python exercises that deal with or revolve around the topic of file handling and exception handling, okay, in Python. You know, from exercise 60 to 63, we've worked with those few exercises that dealt with the topic of dictionaries in Python. So these ones will be about file handling and exception handling. Also, I should mention that if you have not noticed or if you just didn't know, you'll notice that Spider IDE is looking a bit different, than what I've been using in my previous videos. That's because I actually installed a new version of Spider IDE today, so it is pretty cool. I really like this new design. So if you are into Spider IDE, you go ahead and check that out. It's really cool. They've made it much more aesthetically pleasing as an IDE, and everything just looks much more streamlined. So anyway, let's get to our exercise and we'll discuss and code it out together. Exercise 64. Unix based operating systems usually include a tool named head. It displays the first 10 lines of a file whose name is provided as a command line parameter. Write a Python program that provides the same behavior. Display an appropriate error message if the file requested by the user does not exist or if the command line parameter is omitted. Okay, guys, so this exercise is one that's super interesting, right? It's kind of different from the ones we've been doing so far, in an essence that we are going to be creating kind of like our own command line interface, right? And for those of you who are unsure or just don't know what a command line interface is, it's often called a CLI. And just like how you have a GUI is windows and icons and so on, right? So just like how you have a GUI, you get this thing called a CLI, a command line interface. So instead of navigating and working your way around the environment by clicking icons and buttons and so on, you issue textual commands. Okay, and these textual commands help you to get the work done. So personally speaking, CLIs are much more powerful than GUIs, right? And they are less. They basically are less resource intensive, which means they are easy going on your CPU, on your RAM, and so on. So that's just a bit of insight there. So the basic idea of this program is for us to mimic. We're going to code a Python program that mimics the behavior of a command that's available in a Unix based operating system. The command is head in Unix, and what it does, it will display the first 10 lines of any file whose name is provided as a CLI parameter. So we are doing that but in Python. Okay, so let's get to it, guys. First things first, we will be using the sys module. Sys module is built into Python. If you are unfamiliar with this module or you have not really taken the time to kind of dive into the module, it is a super powerful module, the sys module. And I'd also recommend you have a look at the OS module in Python. I'll probably make a tutorial about these modules in the future. Time is the most important factor, so I'll make some time gradually to cover up these kind of topics. But basic on a high level overview, the sys module allows us to manipulate our runtime environment. Now, runtime environment, by that I mean it allows us to directly communicate and issue commands to our entire Python environment, which basically means the IDE that you are using, right? You can issue command line interface commands to your IDE software, and you'll really get some good stuff done. So the OS module is also very similar in a sense that it also supports the command line interface technique, and the sys module allows us to interact with our runtime environment. And the OS module allows us to directly communicate and issue commands really to the OS, or the operating system of our device. So it is interesting stuff. Okay, so first things first, I'm going to begin by importing my sys module. Sys module is built in. You don't have to worry about installation or anything of that sort. So just directly import that. We set up a constant named numLines. You can call yours anything you like. So we'll set that equals to 10 because, you know, they want the first 10 lines. So within my if statement, if length of sys.argv is not equal to 2, print you must provide the file name as a command line parameter. Okay, that's catering for if in the event the user does not give the required input. They specifically told us, right, an appropriate error message if the file requested by the user does not exist, or if the command line parameter is omitted, which basically means it's missing, which means the user did not give the required input for the program to run. Okay, so this is what's happening now. I won't be able to explain everything about the sys module in one video, so I'm just going to summarize where I can, right? You know the sys module here, so we're getting a function from it called argv. So argv is literally a list, right? Argv is a list, and it's this argv function. Given the fact that it's a list in nature, you see, it's this thing here that's basically responsible for collecting the parameters that are passed to our command line interface prompt in Python, which means, you see, IPython console itself is a command line interface, right? So what I'm saying is that, you see, the argv, when we call our function, or when we are going to run the function, and, you know, we pass in our arguments, you know, sample.py run, and then, you know, we pass in any other form of input. You know, you can pass in hello world or something of that sort. What I'm saying is that it's really, you know, after the word run is a built-in keyword. So argv is really collecting all of these arguments. It's collecting all of these parameters that are passed in the command line interface. Okay, so I hope that makes sense. And because of the fact that, you know, argv is a list, we have the ability to find the length of it. We can, you know, perform some comparisons with the length, and all in all, that's what we are doing there. So in the event the user does not give us the proper input for our program, really what we want to do is call the sys.exit. As implied by the name, it will end the interpreter session. It will end the execution of the program. So that's self-explanatory. Now, it's very good practice to pair file handling with exception handling. Okay, exception handling, I have videos on it on the channel. So, you know, if you are new or you'd like to recap with your exception handling in Python, you can watch those videos. So essentially, the most important ones we have is the try and except, which we'll be using in this lesson. So we begin the try and except block by opening a file. You know, we use the open keyword, and we'll be opening a file with the name sys.argv at index 1. In what mode? We'll be opening it in read mode. After that, we'll basically have line is equals to file.readLine. Readline is a method supported by file objects, and it reads one line out of the file, the topmost line, right? So that's fine. Count, we'll have a little counter variable for us, and essentially we need to loop. We know for a fact that we are going to retrieve 10 lines, but you can't use a for loop, right? Because we don't know how many lines actually exist in the file. The limit is 10, yes, right? The limit is 10. We are going to be reading a maximum of 10, but we don't know if 10 lines are really what exists in the file, right? What if we only have 2 lines, and you set up a for loop and you're still trying to read those required 10 lines when there's only 2 that exist? right? So it's for this reason, because of the fact that in essence we don't know how many lines we are reading, so we'd use a while loop. You know, I always mentioned in the previous videos, for loops are used for situations when we know exactly how many times we want to loop. In this situation, however, even though we have a fixed number, we don't know how many lines exist in a file, so we use a while loop. Anyway, let's do a count less than num lines and line not equals to blank. So that condition is self-explanatory, guys. While count is less than the number of lines, so that's the one we set up as our constant, and line is not equal to blank. Line in this case is the read line, which means if the line is blank, there's nothing there for us to read, and the while loop will end. So within the while loop, let's set up what exactly we need to do. So first things first, we are going to call the line is equals to line.rstrip. The reason for this kind of redundancy, where we say line is equals to line, it's not redundancy, it's really the way in which we're supposed to work with strings in Python. Strings are immutable. The rstrip function that's able to be used on a string object will allow us to remove all trailing white spaces, right? So leading and trailing, those are two words you need to be familiar with when you are dealing with strings in Python. Okay, leading, trailing. So I will take this out just now. I'm just giving you a bit of insight into what these words mean. So leading white spaces are these: A, B, C, D, E, F. Those are leading white spaces: A, B, C, D, A, B. Got my alphabet messed up there: A, B, C, D, E, F. Okay, guys, so just take a look at this. This is kind of like a good representation of the concept of leading and trailing white spaces. Okay, R strip will remove the trailing white spaces. Okay, which basically means that after we call the rstrip method on this trailing variable, we'd end up with something like that. Okay, white spaces that are trailing are removed. If there were white spaces before and after, the rstrip would only remove these ones. Okay, so that's important to know and interesting. So anyway, coming back to our while loop, line is equals to line dot rstrip, count is equals to count plus 1. That's fine. Let's print the line of text to the console for us to view. And within this while loop, line is equals to file dot read line. As you know, this will ensure that the while loop continues running. Okay, so within our try block of code, after we finished working with a file, it is very good Python practice to close the file that you have been working with. For that, we use the close method as you see here. Okay, it is called on a file object. Okay, so except exception, we are not specifying what exception. Any exception that occurs in the program will be caught by this except block of code. So really all we want to do is just tell the user print an error occurred while trying to, or let's say while accessing the file. That's good. And really, guys, that's all we have for this program, right? I do hope this was interesting and you are finding it interesting. And most importantly, I hope you are understanding the concept, right? So file handling, as you can tell, is really powerful and very interesting. Okay, and I recommend you experiment and read more about the sys module and the os module, and I'll definitely try to have my own tutorial out there for you guys to watch or just learn from. So with that, you know, guys, we've effectively finished coding this problem. Okay, now the next step after coding something is to actually test it. And how do we test it? While we run the code. So as you can see, I have a file, another file opened up here. It's called DPA extra. So this is just a file I'm using, right? It's a random file on my PC. Well, not totally random. It's my data structures and algorithms module in Python, which I am working with for this block of university. So it's nothing too major. It's just a simple binary search tree I have here. But the point is, we want to read the code from this file. So save this program. Now we head over to our command line interface. The way in which we are running this script is not, the standard way by pressing this run button or so on. We're going to be running the script using textual commands from our command line interface that's built into Python, which is the IPython console. For this, we'll use the magic function. So if you are familiar with Spider, or I'm not sure if other IDEs also support magic functions, you guys can let me know in the comments. Spider is one of the most common IDEs I use. I really like it. So a percentage run is basically a built-in magic function or magic command in Python, and it's used to run a file, a script. And in this case, we are running the script with the name Python exercise tutorial series. So you guys probably must have been wondering why I have these two comments here. So these are basically the parts to my files. Saves me, having to type it out while we are on the video. So take a moment to understand this, guys. The argv list is currently in the process of, or it's going to be in the process of collecting these values as parameters or arguments, okay, for my CLI. So the first argument we passed is the name of the file we're going to execute. The second argument we're passing is the file we want to read from. Okay, very important, guys, which explains why in the code we are opening a file that's taking on the position of argv1. Python is zero indexed, right? So the first one we see here is really the name of the script we want to run, which is argv0, and argv1, which is this one. And as you see here, it's the file that's being opened for reading. So I hope that makes sense to you. And to ensure we are reading correctly, I have this file open, the one we are reading from. When I hit enter, as you can see, I've hit enter, we get the 10 lines, first 10 lines. So it starts at coding and ends at self.left equals none. And that's that. A super interesting program. I'd love to make my own tutorial on the sys module and the OS module, all in due time though. Apart from that, I hope you have new takeaways and interesting takeaways of, some more Python features. And with that, thanks guys for using my channel to help you educate yourself. Thank you for your time. Thanks for watching and staying till the end. Good luck with your work, and I'll see you in the next YouTube video.